This is Dr. Holt. This presentation is on vectors, dot and cross product. First thing, let's talk about the dot product. When you multiply two vectors, sometimes you get a scalar quantity. When we do this, it's called the dot product or the scalar dot product. Dot product is used to calculate work, electric and magnetic flux, in which you do not create a vector. They're just a scalar quantity. When you multiply two vectors, again, you get what's called the scalar dot product. Now let's think in polar notation. You could have two vectors. A could have a magnitude of A, and it could be at some angle. B could have a magnitude of B, and it could also be at some angle. The dot product between two vectors A and B is defined by the equation A dot product B is equal to the magnitude of A times the magnitude of B times the cosine of theta, where theta is the angle between the two vectors. Okay, so this example, I have vector A. It has a magnitude of 12. And again, this could be pretty much any type of unit here. It has an angle here of being 30 degrees. I have another vector B, has a magnitude of 5, and it has an angle of 65 degrees. So first thing you want to do, you want to find out what the angle is between the two vectors. So in this case, the angle would be 65 minus 30, which gives me the 35 over here. So all I have to do is take 12 times 5 times the cosine of 35, and I can find out the dot product is 49.15. Okay, now another thing, if I know what the components are of the vector, all I have to do is take the x components, or it could be the i's. You multiply those two together. You add it to the two y's or the two j's, and you add it to the two z's or the two k's. That also produces what's considered the dot product. Okay, let's look at this example here. Here I know the components. I have A has a 3i, a minus 4j, and a minus 5k. B has the components of 2i plus 7j plus 3k. So I'm going to multiply the 3 and 2 together here. I'll multiply the negative 4 and 7 here. Multiply the negative 5 times the 3 here. And all I have to do is add those up. So the dot product of A and B will be equal to negative 37. Now what is the significance of the dot product? Dot product being, for example, if you know what the dot product is, if you can calculate the dot product and you can calculate what the magnitude is of each vector, then you can find out what the angle is, what the angle would be between the two vectors. Alright, another way to look at it is what you're really doing, and this you can think about this in terms of, say, work, where you're doing force times distance, and force and distance have to be parallel to one another. What I'm really doing is I'm just taking B. I'm taking the vector B. I'm multiplying it times the cosine of the angle between it, which gives me this component right here. And then I'm just multiplying that by vector A. When I do that, what I'm doing is multiplying two vectors together that are parallel. Okay, in the following video, I'm going to demonstrate how to conduct or how to do a dot product of two vectors. Okay, let's look at these two vectors. Let's say we have u vector, and u vector is going to have the components of 2i hat minus 3j hat plus 6k hat. And we have another vector, v, which is equal to 2i hat plus 5j hat minus k hat. And what we want to do is we want to find the dot product. So we want to find out what u dot v is. Okay, so what we're going to do in this case is you're going to multiply the two I component, the coefficients of the i's. So that's going to give me 2 times 2. And now you're going to add a negative 3. I'll go ahead and put these in parentheses. Negative 3 times 5 plus 6 times negative 1. So when we do that, that's going to give me 4 here. That's going to give me a negative 15 here, and that's going to give me a negative 6. So we add those up. then we'll find that the dot product of u dot v is going to equal to negative 17. All right, and again, this is a scalar quantity. This is not a vector quantity. Now, if we want to find the angle between these two vectors, we go back to the equation that the cosine of theta is equal to the dot product of u dot v divided by the magnitude of u times the magnitude of v. All right, so we just need to really figure out what the magnitude of this is going to be. So let's find out what the magnitude of u is going to be. The magnitude of u is going to be defined as the square root, and all we have to do is, come back up here, is we're going to take 2 squared plus minus 3 squared plus 6 squared, and we're going to take the square root of that. So we go to 2 squared plus a negative 3 squared plus 6 squared. When we do that, we will find that the magnitude of u, I need to put this too, it's like that, magnitude of u is going to equal to 7. Okay, we do the same thing for v. The magnitude of v is going to equal to the square root of 2 squared plus 5 squared plus minus 1 squared. And if we add those up, we'll get the square root of 30. Alright, so let's go ahead and write our equation down so that we can say the cosine of the theta being the angle between the two vectors, is going to equal to the dot product, which we said was negative 17. We're going to divide that by the square root of 30, and we'll multiply that by 7. I can have these switched, but it makes no difference. Alright, so to find theta is going to equal to the inverse cosine of negative 17 divided by the square root of 30 times 7. And when we do that, we will find out that theta is equal to 116.3 degrees. Alright, so we've determined what the angle is between the two vectors. And this is the approach you use. And then again, it's fairly simple. You're pretty much basing everything just off of this equation right here. This example here. So let's say we want to find what the angle is between two vectors. A has the components of 2, 2, and negative 1. B have the components of 5, negative 3, and 2. Again, that represents your x, your y, and your z values. Alright, so first thing I can do, I can determine what the magnitude with the A would be and the magnitude of B. So in this case, I just go back 2 squared plus 2 squared plus negative 1 squared. I take the square root of that and I get a 3. So the magnitude of vector A is going to be 3. I do the same thing with B using its components. The vector B has a magnitude of the square root of 38. Alright, now if I take the dot product of those two vectors, then I'm going to multiply the 2 times the 5 and the 2 times the negative 3 and the negative 1 times the 2, just as I did here, and I add them together, and I find out the dot product is going to be 2. Now, since I know the magnitude and I know what the dot product is, I can go back to the equation that the cosine of theta is equal to A times A dot product B divided by the magnitude of A times the magnitude of B. So I take 2 divided by the two magnitudes, which is 3 times the square root of 38. I take the inverse cosine of this value here, which gives me an angle of 84 degrees. Okay, things to note. Two non-zero vectors, A and B, are called perpendicular or orthogonal if the angle between them is going to be pi over 2, which makes that 90 degrees. Now we know that because we know the cosine of pi over 2 is going to give me the value of 0. So I can say the dot product of AB is going to equal again times the magnitude of A times the magnitude of B. As long as this angle is pi over 2, I'm going to get 0. So conversely, I can also say that the dot product of A dot product B has to be equal to 0. So if anytime I calculate the dot product and I get a 0, then I know the two vectors are perpendicular to one another. So we state that two vectors, A and B, are orthogonal if and only the dot product is equal to 0. Alright, so let's look at the dot product here, and we're going to show that the vector here, 2i plus 2j minus k, and the vector 5i minus 4j plus 2k are perpendicular. Once I do the dot product here, I get a 0. That tells me immediately that they are perpendicular to one another. Okay, cross product. Many applications in physics, or even in engineering, involve finding a vector in space that are right angles to one another. We call the multiplication of this the cross product. This is often used in engineering, especially in calculating torques and moments, used in physics, also in calculating torques or angular momentum. The cross product is defined as the magnitude of the cross product of A, B, and we set that equal to the magnitude of A times the magnitude of B times the sine of theta. So two non-zero vectors A and B are parallel if the cross product is equal to 0. Now the right-hand rule is very important to know because it's going to tell you what direction you're going to get of the new vector. Remember, when you calculate a cross product, you're getting a new vector. Now the way you do that is, for example, say I want to find out what the cross product of V is. I'm going to take my fingers and I'm going to point them in the direction of the U vector. And then I'm going to wrap my fingers toward the direction of V. When I do that, then my thumb is going to point at a 90-degree angle to this plane right here, and that's going to be the direction of my new vector. Now, say I wanted to do the cross product V times U. Again, I would point my fingers in the direction of U, but look what, or V, and I'm going to move my hands toward U, and when I do, I'm going down. So I've changed the directions of the cross product, and the vector is going in the opposite direction. The definition. Now, to do cross product, basically what you're going to do, and I highly recommend this, is just set up a 3x3 matrices and go ahead and do the determinant. You notice here I've set up an I, J, and K. I'll put the coefficients for the two vectors across here and across here, and I will just follow the determinant. And I have another video on determinants if you're confused about how to do that. Okay, in the following video, I'm going to show you how to calculate the cross product of two vectors using determinants. Okay, I want to go over the cross product of two vectors. Let's say we have vector V. And vector V we'll define as being 2 I hat minus 3 j hat plus k hat. And we'll have another one, we'll call it W vector, and we'll establish it as 3 I hat minus 2 j hat minus k hat. Alright, so now let's talk about this. Let's take the cross product of V cross product of W. Alright, now how I recommend you guys do this is go ahead and just set this up as a 3x3 matrices. So we'll set up I, J, oops, it's close up, J, and then K. Alright, we're going to set the coefficients up. We got a 2, we got a negative 3, we have a 1, we have a 3, we have a negative 2, and we have a negative 1. So this is our 3x3 matrices. Now remember, when you're doing determinants, you must remember that the signs change. So you have a positive minus positive minus positive minus positive minus positive. So you got to remember that when you're using the i's, j's, and k's. So let's go ahead and work the first one. We're going to work the i's first. So to do that, we're going to take a minus 3 times a negative 1, and then we're going to subtract 1 times negative 2. So what I'm doing is I'm going to do the I. So I'm not going to use this column, and I'm not going to use this row. So it's going to be negative 3 times negative 1 minus, going down this way, 1 times negative 2. Again, we're just following the rules of the determinants. and that part here will be my I. Okay, now I'm immediately going to subtract because I got a negative here. Slide this over a little bit. So now we're going to do the other one, and it's going to give me a 2 times a negative 1 minus a 1 times a 3. And that'll be my j. And again, what I'm doing here is I'm taking the 2 times a negative 1 minus the 1 times the 3, and that's how I'm getting these values here. And then I'll go down to the next line. Usually you should do this in one line, but run out of space, so we're going to do the positive, and now we're going to do the k. When we do the k, we will get a 2 times a negative 2 minus a negative 3 times a 3. And we'll define that as k. And again, let me go through where I'm coming up with that. That's going to be 2 times negative 2 subtract negative 3 times 3. And that's why I got these values here. All right, when I finish up, I will get this. I will get 5i plus 5j plus 5k. And again, these values just happen to be the same. So the new vector that I've created is at right angles to v and w using the right hand rule, so we can say the cross product of v w is going to be this vector right here, and we can go ahead and make that hats if we want. Alright, now let's change the problem a little bit. Let's look and see what happens when we reverse this. Let's do the cross product of w times v. Okay, so now if we do that, we need to rewrite this. So our new matrix is going to be I, our j, and our k, and we change our rows. I've got 3, negative 2, negative 1, a 2, a negative 3, and a 1. Okay, and again, we're going to follow this sign convention when we do this. So we'll go ahead and start putting those numbers in, and I'll see if I can get this all in one row this time. So that's going to give me equals to a, start with the I, it's negative 2 times 1. That's a negative 2 times 1 minus a negative 1 times negative 3. And again, you got to be very careful about this. It's really easy to make mistakes, and it's a good idea just to practice some determinants. And that's going to give me the I value. All right, now we'll do the other one. That's going to be a minus. And when I do that, I'm going to get, when I do the j, I'm going to get 3 times 1 minus negative 1 times 2. So it's going to give me 3 times 1 minus a negative 1 times 2. And that'll give me my j value. And let's see if we can squeeze the k in there. And then that's going to be a plus. And my values will be 3 times a negative 3 minus a negative 2, boy, that's going to be tight, times 2, and that's going to give me the k value there. Alright, so let's go ahead and simplify that. When I do that, look what happens here. W, the cross product of w cross with v, is going to give me a negative 5i minus a 5j minus a 5k. And I'll go ahead and put these as hats. So I created a new vector that's right angles, but obviously since these are negatives compared to these, it's going to be rotated 180 degrees. It's going to be pointing in the opposite directions. Okay, so this is how you do cross product. Again, you're just going back and using determinants. And then the other properties here are listed below. Okay. In this example, I want to find a unit vector that is orthogonal to 3i, 2j, k, and I plus 5j minus 2k. So what we're going to do here, we're going to begin by doing the cross product of the two vectors. So again, I set up my matrices, my I, j, and k. I put my coefficients in. And this is very similar to what I did in my video. Go ahead and calculate what the determinant would be using these values here. And I get minus I plus 7j plus 7k. Now note, it asks for the unit vector. So what I'll have to do would be, in this case, I would have to divide it by the magnitude of the new vector that I've just created. And again, to do that, I just come back here. I got a -1. I square that, gives me 1. I have 7. I square that, it's 49. 17, I square that, it's 289. I add that together, and that's going to give me the square root of 339. So the unit vector would be defined as this. Okay, note, the best way to get good at doing dot products and cross products is just through practice. Some of this may seem a little complex. Again, just review it a few times and work several problems, and you'll be good to go with this.